Mr. A.B. Pandya, who is a former chairman, Central Water Commission, and Mr. Pandya will be talking on the topic learnings and opportunities for improving geospatial technology adoption in the water sector. Over to you, Mr. Pandya.
Today we will be talking a little bit about the learnings and opportunities for improving the geospatial technology adoption in water sector. In fact, if we look at it, we find that water sector, especially in India and abroad, has been a very prime user of geospatial technologies right from its inception. And at Central Water Commission and at the government level, we have been the major consumers of the remote sensing data that gets generated through the NRSC, and we have benefited a lot out of these exercises. So rather than going into the individual technologies, let me go through the constraints that are there in the water resources sector, where the geospatial technologies have a very strong role to play in order to provide the solutions and in order to provide the insights. India is essentially a water-stressed country, as you can see. We have got the land resources of 2.45%, but the population at 17%, and then water is so closely associated. We are a little bit better at renewable water resources of 4%, but still, with the ever-growing population, it's a big challenge for us to have these water resources reaching everybody. We have a total precipitation of 4,000 BCM, and out of which a lot of water goes in form of evaporation and various other losses, and the total water availability is restricted to only 1869 BCM, which is slightly less than 50% of what you actually receive. And then out of that, we have utilizable water, which is not contained in any kind of extreme floods, etc. That is at 1123, and from there, the surface water is assessed at 690 BCM, and groundwater has been assessed at 433 BCM. We recently carried out an exercise, and there are slightly different figures that are available now, but then those figures are yet to come in the circulation. Now, essentially, even though it looks like a lot of water is available, but the availability, which is highly dependent upon the rainfall, as you can see, is something which is very, very skewed. We have very large parts of the country where the rainfall availability is extremely less. There is hardly any in this tropical part of the countries. There is no possibility of any other kind of precipitation other than the rainfall, and therefore the amount of water that is available in these areas is extremely limited. Whereas there are areas which are having very good availability of water, but then they are restricted in extent, and they are far away from the areas which are needing water. And this essentially requires us to manage the water in a global sense in order to provide an equitable regime. And for that, as you can see, we will also need to have long transportation of the captured water, utilization in an area specific manner, which is in tune with the available climate and available land resources, and then maintenance of all these extensive systems. So herein lies the real requirement of the geospatial technologies, which can provide us with a global view, which can also provide us with a local view to the extent of required details, and therefore allow us to manage the water in a rational sense. This was as far as the aerial distribution is concerned. Now, when you look at the temporal variation of the rainfall, we have a very little window in which most of this water occurs. And when this kind of situation is there, you will suddenly get a lot of water, and then you may not have any adequate amount of water for the growing population. Whereas now, with the growing industrialization, urbanization, and also the intensive agriculture that we are practicing, we need water almost in equal quantities throughout the year. And for that, we need to balance the storages, and the supplies. For this purpose, again, the geospatial technologies are the ones which comes to our rescue. We are able to identify the sites through the 3D mapping. We are also able to carry out the precision surveying. And then we also are able to manage this through GIS-based real-time telemetry and the flood forecasting, so that we know how much amount of water we are going to get in the reservoirs. Similarly, we are also able to manage and work out the demands, which are the potential demands. Again, this is a very micro level exercise where we practically need to know almost in every major land segment what is the kind of precipitation that has occurred, what is the temperature regime over there, what is the wind speed over there, how much amount of evapotranspiration will be there, and accordingly we can assess that this is the kind of demand that is going to be there, because a particular type of crop that is growing in this particular agroclimatic context. The remote sensing and the geospatial data from various sources, and we have been able to integrate this information into our normal working. In fact, the as far as the various applications are concerned, one of the landmark application that was developed using all these technologies is this India Water Resources Information System, which is available for all the people to use. And it's a very exhaustive system in which we have been able to provide almost every data that is relevant to water resources sector, and even preliminary planning, etc., can also be thought about using this system. We have also been one of the forerunners in establishing the technology for working out the sedimentation loss of capacity in key reservoirs in the country, and that has helped us in updating the storage situations in the country as far as the water resources are concerned. Um, we also had a very good use of these technologies right during the inception of this national mission on clean Ganga, wherein we could identify various types of population centers that are located along the banks of main river Ganga, and their potential towards the creation or management of the pollution. Um, Another inventory that we could prepare using this geospatial technologies was the water bodies and also the glacial lakes that are also have a lot of potential of causing the disaster. So these are the very good way forwards, but still we need a lot of capacity building in this sector, especially on the front of the consumer engineers or consumer professionals who are working in the sector. We need to actually work very hard in order to see that the technology becomes ubiquitous. That means I would like to say that a civil engineer or a person who is working in the water resources should be as comfortable with these technologies as the person is comfortable with, let us say, something like say Microsoft Word or Microsoft Excel. That will actually help us to a great extent in better managing our decisions, optimizing the resources, and providing the water, food, and energy security. Towards this end, in my present assignment as Secretary General, International Commission on Irrigation and Drainage, we are having a very strong network of the professionals who are working in the agriculture water management, and they use the remote sensing and geospatial technologies very extensively. But all the same, we need a better association with the geospatial industry in these areas, so that the young professionals and various other professionals who are practicing this can be benefited out of the new technologies and knowledge that is getting generated in this area. We are also going to very shortly we are going to launch, through the help of World Bank, a forum called Inspire, in which we will try to collect all the irrigation service providers. And again, I feel that in this forum, the geospatial industry can make very significant contributions in enhancing the knowledge and providing the additional capacities. So I would thank you all for listening to my interrupted presentation, and we look forward to very close association from the geospatial industry in order to better manage the water, energy, and food nexus around the world. Thank you very much.